Hi, I'm Jadyn,
I'm Asma.
And I'm Lydia.
and today we'll be talking about biodiesel.
So, our original problem was started from global warming and what we could do to help. Carbon emissions from cars is a huge detriment to the atmosphere. We want to introduce people to the option of biodiesel since it's recycling wasted cooking oil.
Our hypothesis was regardless of the type of oil, the quality of the biodiesel will remain the same.
When we conducted this experiment, we started off by heating up 200 milliliters of the three different oils, canola, olive, and vegetable, on separate hot plates. They were to be heated until they reached 110 to 125 degrees Fahrenheit. As the oils were heating, 4 grams of lye was poured into 50 milliliters of methanol and mixed until dissolved. 3 separate lye and methanol solutions were made. By then, the beakers of oil had reached the desired temperatures and were moved under a fume hood, where the lye and methanol solutions were then poured into each as they were stirred. We then left the mixtures in the fume hood for 24 to 48 hours so the biodiesel and glycerin would set and separate. In our first trial, our experiment resulted in little to no biodiesel production, but with minor changes in our second trial, such as closing the fume hood completely and checking the mixture sooner, we were able to produce 40 milliliters of biodiesel in the canola oil, 30 milliliters from the vegetable oil, and 20 milliliters from the olive oil.
The graph represents our observations throughout the experiment. The olive oil's reaction was becoming a lighter color with gas production and a production of a new substance, although it had the weakest reaction, while the canola became darker in color and had the strongest reaction, and the vegetable oil remained the same color and had the strongest reaction as well.
The first 4 images show the actual process during the experiment. In the first image, you can see us mixing the lye and the methanol in a beaker, and you can see us pouring that into oil, and following the next images, you can see the reaction the oil had and the end product of the biodiesel and glycerin. At the bottom, you can see that in our second trial, we actually ended up producing biodiesel, so you can see the beakers that we had each of the different oils in.
The first question in our data analysis asked, what does glycerin production mean for biodiesel? Well, biodiesel goes through a process called transesterification, in which glycerin separates from the fat and oil that leaves methyl esters.
Which oil produced the least amount of glycerin? Olive oil had the least amount of biodiesel produced due to its refinement. This was also the most expensive oil, which shows biodiesel is inexpensive and eco-friendly. Why did the beaker heat as lye was dissolved into the methanol? A chemical reaction occurs between the lye and methanol, and heat is a sign of it.
Because of the varying levels of biodiesel production, our hypothesis was proven incorrect, which, let me remind you, was that the quality will remain the same. However, with our original problem being to create and find a more environmentally friendly gas or biodiesel, and seeing that the cheaper oils, the canola and vegetable, made more biodiesel makes us extremely hopeful for the future.